In the last video, we were talking about rational functions, and we ended with talking about the different types of asymptotes. We had vertical asymptotes, horizontal asymptotes, and oblique or slant asymptotes. In this video, we're going to start finding our asymptotes. Okay, so let's start with our vertical asymptotes. So locating a vertical asymptote. So remember, our rational functions have the form r of x equals p of x divided by q of x. And q of x cannot equal 0. And for a vertical asymptote, this function has to be in lowest terms. Which means if we're looking at two equations here being divided, then we need to factor them completely and cancel out anything that we can cancel out. Okay? So it will have a vertical asymptote at x equals r if r is a real zero of the denominator. So that means if x minus r is a factor of q of x, then the function r of x will have a vertical asymptote at x equals r. Okay, so we're still looking at the denominator, and we're still taking our terms in the denominator and setting them equal to 0, and the results of that is telling us where our vertical asymptotes are. What makes this different is that when we were finding the domain of a rational function, we needed to factor it completely, but we couldn't cancel anything out. We had to look at all of the terms in the denominator before we started canceling anything out. Okay, so let's look at an example. So let's say I have r of x equals x squared minus 9, and this is being divided by x squared plus 4x minus 21. Okay, so the numerator here is the difference of squares, so I can factor this, and the denominator here is quadratic, and it does factor, so let's go ahead and rewrite this. So difference of squares tells me the numerator is x plus 3 times x minus 3. And this is being divided by, if I factor this, I'm looking for the terms of negative 21 that will add up to give me 4. So x minus 3, x plus 7. Okay, so if I'm just talking about my domain, I have to take x minus 3 equals 0, x plus 7 equals 0, cannot equal, excuse me. So these cannot equal 0. So x cannot equal 3, and x cannot equal negative 7. Okay, so my domain here is x such that x does not equal 3, and x does not equal negative 7. Okay, now for vertical asymptote, though, we need this function to be in lowest terms, which means this x minus 3 in the numerator and this x minus 3 in the denominator cancel each other out. So here, for my vertical asymptote, I'm just looking at x plus 7. Okay, so this over here is equal to x plus 3 in the numerator, x plus 7 in the denominator. Okay, so my vertical asymptote, I'm only looking at x plus 7. So here, I have a vertical asymptote at x equals -7. And I already solved that here, so I can just rewrite it as my vertical asymptote. Okay, so x minus 3 and x minus 3 that have canceled each other out, I still have a domain restriction here at x equals 3. Because that cannot exist as part of my graph, but it is not a asymptote itself. It's actually a hole in the graph. So here I have a hole in graph at x equals 3. And by a hole, I mean a literal, let's say our graph is doing something like this. There'll just be a little hole, and then it'll continue on the other side. Okay? So whatever cancels out after you factor is creating these holes. Whatever is left over is creating our asymptotes. Okay. So factor first, find your domain, then reduce. After reducing, that will give you the denominator terms that you will be able to find your vertical asymptotes. Okay. We also talked about horizontal and oblique asymptotes. Excuse me. So remember, rational equations have the form r of x equals p of x divided by q of x. So here, we want to just have something general. So a sub n times x of n plus a sub n minus 1 x to the n minus 1 plus so on and so on and so on. And down here in the denominator, it's still a polynomial. So let's say a sub m x to the m plus a sub m minus 1 x to the m minus 1 plus dot 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 dot. And they keep going. So the degree of the numerator here is n, and the degree of the denominator is m. Okay, so we don't know what n and m are, but we're talking about rational equations, so we know that they're positive integers. When we're looking for horizontal and oblique asymptotes, we're really looking at the degrees of our equations that we have in the numerator and denominator. Okay, so if n is smaller than m, okay, then y equals 0 is the horizontal asymptote. Okay, so there's not a whole lot of math there. You're looking at whatever equation you're being given, and you're doing it by inspection. You're looking at the exponents on your leading terms in your numerator and denominator. And if the one in the numerator is smaller than the one in the denominator, y equals 0 is your horizontal asymptote. Okay. If n equals m, okay, so if the lead term has the exact same exponent, so if these were both squared, we'd be in this situation. Then you look at the coefficients. Okay, so if this was a square and this was a square, I'm going to look at this coefficient divided by this coefficient, and that is my special line for the horizontal asymptote. And we'll look at some examples here in a minute. Okay. So if n equals m plus 1, okay, so if this is just one bigger than the one on the bottom, okay, y equals ax plus b is an oblique asymptote. And it is found using long division. Okay, so we'll look at an example of using long division to find an asymptote. And if n is greater than or equal to m plus 2, okay, so this was x to the 6th power, and this was x squared. You have no horizontal asymptote. You have no oblique asymptote. And then you can even say that the end behavior is similar to the power function y equals a sub n divided by b sub m, x to the n minus m. Okay? So let's look at an example. So example 1. Let's say we have f of x equals 3x squared plus 5x plus 1 divided by 4x to the 5th plus 3x squared plus 4. Okay, so remember, looking for these asymptotes, I'm really just looking at my lead term here, and the one in the numerator is smaller than the one in the denominator, so I'm looking at n being smaller than m, so n is less than m. And we just learned that if n is less than m, y equals 0 is our horizontal asymptote. So y equals 0 is horizontal. Okay. It would have some vertical asymptotes too. We would have to factor the denominator, see if anything could cancel out, see if we could factor the numerator, see if anything canceled out. But right now we're just looking for horizontal and oblique asymptotes. Okay. So let's look at example 2. Let's say we had the equation f of x equals x cubed minus 8 divided by x squared minus 5x plus 6. Okay. So here I've got 3 and here I've got 2. So n is 1 bigger. So y equals ax plus b is the oblique asymptote. So I need to find it using long division. So I can do that. So let's say x squared minus 5x plus 6. I've got x cubed. And here I'm missing terms. I'm missing my x squared term. I'm missing my x term. I'm going to go ahead and fill them in with zeros. That way I can use them as placeholders as I'm going through this long division. Okay, so remember I'm looking at x squared and thinking, what do I have to multiply to get x cubed? Well, that's just one away, so I need to multiply just by x. So x times x squared gives me x cubed. Then x times negative 5x gives me negative 5x squared. Then x times 6 gives me plus 6x. Okay. Then remember we go through and we change all of our signs. Negative, positive, this becomes negative. The entire point of this was to make these leading terms cancel out. So here I've got 5x squared minus 6x minus 8 comes down. Now I'm looking at x squared and thinking, what do I have to multiply to get 5x squared? So here I just need to multiply by 5. So that gives me 5x squared. Okay, minus 25x plus 30. And we go through and change all of our signs. Negative, positive, that becomes negative. Okay, so these cancel out. 25 minus 6 gives me 19x minus 38. And here we're done. X plus 5 right here, this is my expression that is my oblique asymptote. Now, if we wanted to, we could go ahead and find our vertical asymptote for this equation right here. We're also checking for the possibility of any holes in the graphs. Okay, so we didn't have a horizontal. Let's look for a vertical too. In order to find a vertical, remember I have to have this completely factored. So I have the difference of cubes in the numerator, and then I have something quadratic in the denominator. So f of x equals x cubed minus 8 divided by x squared minus 5x plus 6. Okay, that is equal to x minus 2, x squared plus 2x plus 4. Remember, you have a formula for the difference of cubes. Then I'm looking for the factors of 6 that will add up to 5. So x minus 2, x minus 3, they both need to be negative since this is negative and this is positive. So now these two cancel out, so I have a hole in graph. At x equals 2. So I'm only looking at this term here for my vertical asymptote. So if I were to set this equal to 0 and solve for x, I would have x equals 3. So I have a vertical asymptote. At x equals 3. And then my domain is x such that, remember, for my domain, I have to use both of my terms before I've canceled. So x cannot equal 2, x cannot equal 3. Let's look at another example. Let's say we have f of x equals x squared plus 6x plus 5. And that's divided by 2x squared plus 7x plus 5. I want my horizontal asymptote. I want my vertical asymptote. I also want to find my domain and see if I have any holes in the graph. So let's just go ahead and start with factoring this. I'm looking for the factors of 5 in the numerator that are going to add up to give me 6. Everything is positive, so I have x plus 1, x plus 5 in the numerator. Then in the denominator, this also factors. So I've got 2x plus 5 times x plus 1, the denominator. So to find my horizontal asymptotes, I need to be looking at my unfactored form. So here I've got 2 and 2, so they're both squared. My leading terms are both squared. So I am in this situation of n equals m, and we like n equals m. Just the coefficients. So here I have a coefficient of 1. Here I have a coefficient of 2. So y equals 1/2. Okay, this is my horizontal. Now, let's see. My domain is x such that I'm solving both of these here for my domain. If I set them both equal to 0, so that tells me x cannot equal -5/2 and x cannot equal -1. Okay, but I have x plus 1 in both numerator and denominator. I know those are going to cancel out, so I have a hole in my graph. At x equals -1. And then what I have left over in the denominator, this is what's telling me my vertical asymptote is. So I have a vertical asymptote at x equals -5/2. So there's a mnemonic that helps people remember how to find horizontal asymptotes. And it's BO, BO, BOTN, EATS, DC. BO, BO, BOTN, EATS, DC. So bigger on bottom, y equals 0. So bigger on bottom, 0 is your asymptote. Bigger on top, there is none. Okay. If exponents are the same, divide coefficients. So if you're the type of student that uses mnemonics like this to help you remember things, that's generally used. Just remember, you can find all of these by factoring. What cancels out is giving you holes. What's left over is your vertical asymptotes. And you really just have to remember those 3 rules about the horizontal asymptotes. Okay? I'm going to go ahead and stop this video here for now. The next video, we're going to actually start graphing rational functions. I haven't graphed very much, so we'll look at a couple of examples to develop those skills.